130 million light-years away, two dead stars showed us what gold can mean. The story does not start in a mine. A mine only exposes it.
Earth only stored it.
Long before Earth, long before the solar system,
atoms like these had to be assembled somewhere ordinary stars cannot finish the work. Pull back from the ring. Pull back from the coin. Pull back until the metal stops being a human object and becomes a trace of nuclear physics. In the dark,
two dead stars orbit each other. Each is only about the size of a city. Each carries more mass than the sun. Their surfaces are not surfaces in any familiar sense. This is matter crushed so hard that atoms have lost their normal shape. The orbit tightens. Space itself begins to ring. The first sign is not an explosion. It is a rising gravitational wave, a chirp stretched across about 100 seconds. Then the collision comes. A fraction of neutron-rich debris is hurled outward. Inside that debris, atomic nuclei are driven through rapid neutron captures.
Heavy elements can be assembled there.
Not only gold, but platinum, uranium, and other material ordinary stellar fusion cannot easily make.
That is the doorway. Not a myth about precious metal.
Not a claim that one observed collision made your exact ring. The stronger story is colder and more useful. In 2017, astronomers caught one of these events in gravity and light at the same time. Its name was GW 170817. It came from NGC 4993, about 130 million light-years away, and it gave science one of its cleanest clues that some of the heavy matter on Earth was forged in dead star collisions. A normal star is already a nuclear furnace. It fuses lighter elements into heavier ones. Releasing energy becomes helium.
Later stages in massive stars can build carbon, oxygen, silicon,
and eventually iron group elements. Then iron changes the bookkeeping. Fusion up to iron can release energy. Fusion beyond iron usually costs energy. So a star cannot simply burn its way upward, step by step, into large amounts of gold. The periodic table does not extend by ordinary stellar patience. For many of the heaviest nuclei, the universe needs another route. It needs nuclei to capture neutrons faster than they can decay.
That route is the rapid neutron capture process, or R process. The name is technical because the physics is technical. The picture is cleaner. Imagine a seed nucleus caught in a storm of neutrons.
Neutrons slam into it. The nucleus becomes unstable. Then some neutrons transform into protons through radioactive decay, changing the element itself. Repeat the cycle under the right conditions, and matter can climb into regions of the periodic table that normal fusion cannot build in bulk. The key requirement is not just heat. It is neutron richness. You need neutrons available in extreme density, on extreme timescales.
A neutron star is almost that requirement made into an object.
It is the collapsed core left after a massive star dies.
Gravity has compressed matter
So violently that electrons and protons are driven together, forming neutrons. Solar-scale mass is packed into city-scale width. When two neutron stars merge,
some of that neutron-rich
material can be torn loose and thrown into space. That ejected material is where the gold claim becomes physically meaningful. Not because one sentence settles every atom, but because the merger gives the R process an arena powerful enough to build heavy elements fast. On August 17, 2017, the first messenger was not light. It was gravity, gravitational wave detectors in the United States, with Virgo in Europe helping narrow the sky position, registered a signal unlike the shorter black hole mergers that had already opened gravitational wave astronomy. This one lasted about 100 seconds. That duration mattered. A long inspiral is exactly the signature expected when two neutron stars circle each other before collision. The signal was named GW 170817. Then the second messenger arrived. The Fermi Gamma Ray Space Telescope detected a short burst of gamma rays about 1.7 seconds after the gravitational wave signal.
The delay was short enough to link the events,
and precise enough to become one of the most important timing details in modern astronomy. Gravity had said, something compact just merged. Gamma rays said, the merger also made light. That pairing changed the search. A gravitational wave can point to a broad region of sky. It can tell scientists that mass moved violently. But light can be localized. It can be followed. It can be watched as it fades.
With Virgo included, Astronomers had a small enough search area for telescopes to hunt across a manageable patch of sky.
The source was found in NGC 4993, an old galaxy about 130 million light-years from Earth. That distance matters. GW 1708-17 did not happen near us. It did not seed Earth with gold after humans were here.
The collision happened long before its signal reached our detectors.
By the time those waves crossed Earth, the solar system already had its chemical inventory. So the observed event is not the literal origin of a specific object in your hand. It is more valuable scientifically, a close enough example of the mechanism, caught with multiple messengers, giving astronomers a real event to measure instead of only a theory to simulate.
The light that followed was not an ordinary supernova. It was a kilonova, smaller, faster, stranger.
Powered by radioactive decay inside freshly made expanding debris.
After the neutron stars merged,
some matter escaped instead of falling into the final remnant. That debris expanded at enormous speed. Inside it, unstable nuclei formed by the R process decayed. Their decay released energy. The energy heated the cloud, and the cloud shone. The color and fading of that light mattered because heavy elements do not just sit in the debris as decorations. They change how radiation moves through it. Material rich in very heavy elements can make the ejecta more opaque, pushing the glow toward redder and infrared light as it evolves. That is why GW 1708-17 became more than a gravitational wave detection. Telescopes could watch the aftermath change. At first, the transient was bright in optical and ultraviolet light. Then it faded and reddened.
Infrared observations became crucial. Later,
X-ray and radio emission helped track the longer-lived afterglow connected to fast outflows and surrounding material. The kilonova was not a pile of gold photographed in space. It was not a spectrum with the word gold written across the sky. The direct evidence is more disciplined than that. The European Southern Observatory later reported the first identification of a freshly formed heavy element,
strontium,
in the aftermath of the merger. Strontium after the merger. Strontium is not gold. It matters because it is a heavy element made in that violent environment. It is direct evidence that newly formed heavy material was present. Gold and platinum enter the story through the broader R process interpretation of neutron-rich ejecta, kilonova light models, and source estimates. The Scientific Visualization Studio at the agency describes the debris from this merger as likely containing hundreds of Earth masses of gold and platinum. But that is a science communication scale estimate, not a bucket weighed in a laboratory. The careful version is still extraordinary.
A dead star collision
Created conditions where heavy elements could be built and thrown into space, and the light behaved the way neutron-rich, radioactive debris should behave. The phrase multi-messenger astronomy can sound like branding. GW 1708-17 made it operational. A gravitational wave detector does not see a galaxy. It measures tiny changes in distance as space-time stretches and compresses.
A gamma-ray telescope does not make a pretty optical image.
It catches high-energy photons from violent processes. An optical telescope can identify a point of light inside a galaxy. Infrared instruments can follow cooler, dustier, or more opaque emission. X-ray and radio observatories can trace later interaction as material drives into surrounding space.
Before this event, those were often separate languages. Here, they became one chain of evidence.
The gravitational wave observatories caught the mass motion. Fermi caught the gamma-ray flash.
Optical telescopes found the transient in
NGC 4993. Space missions including Hubble, Chandra, Swift, Spitzer, and NUSTAR followed different pieces of the aftermath across the spectrum. No single instrument owned the discovery. The event could be reconstructed because different machines were sensitive to different messengers from the same physical source.
That matters for the
gold story because element formation is not visible as a simple photograph. A telescope does not look at a distant galaxy and see a nugget of metal. Scientists infer the physics from timing, luminosity, color evolution, spectra, afterglow behavior, and models tested against observed light. This is the difference between a cosmic myth and a cosmic measurement. A myth says, gold came from a violent place, and stops there. A measurement says, on this date, detectors recorded a long gravitational wave chirp, Gamma rays arrived 1.7 seconds later. The sky position led to a transient in NGC 4993. The glow evolved like a kilonova. Spectra and models indicated newly formed heavy material. Later observations tracked the outflow. The origin story works because it is not only beautiful,
it is constrained.
Now the sentence has to be tightened. 2 dead stars made the gold in your hands is a strong title because it points at a real mechanism. As a literal claim about every atom, it is too clean. Earth's gold is older than Earth. The solar system formed from gas and dust, already enriched by earlier generations of stars and stellar explosions. By the time planets assembled, heavy elements were already mixed into the cloud that became the sun, asteroids, and rocky worlds. Some of that enrichment may have come from neutron star mergers. Some may have come from other rare R-process sites, depending on the element, the galaxy, and the chemical history being modeled. The active scientific question is not whether neutron star mergers can make heavy R-process material.
GW 170817
helped confirm that they can.
The harder question is how much of the universe's gold budget comes from mergers
compared with other sources across cosmic time.
It is safe to say neutron star mergers are a major confirmed site for
making heavy R-process elements. It is safe to say events like these can forge material associated with gold and platinum. It is safe to say Earth's gold had to be made before Earth existed, in extreme astrophysical events that enriched the material from which the solar system formed. It is not safe to say this exact observed event made your ring. GW 170817 was too recent as a received signal and too far away to be the direct donor of Earth's metal. It is also not safe, from this dossier alone,
to say every atom of gold on Earth came only from neutron star mergers. The universe is not required to use one factory.
But caution does not weaken the story. It keeps the story physical. The object in your hand is not a souvenir from one named collision. It is evidence that the periodic table has violent origins. It tells you that Earth chemistry is not only Earth chemistry. It is galactic archaeology. For heavy atoms to reach a planet, the universe has to do more than make them.
It has to mix them.
Material ejected from stellar deaths and compact object mergers spreads into interstellar space.
It cools, dilutes,
and becomes part of later clouds of gas and dust. Those clouds collapse into new stars.
Around some of those stars, disks form. In those disks, dust grains stick,
rocks grow, planetesimals collide, and planets assemble. Gold is rare in Earth's crust, partly because of chemistry and planetary history. Much of Earth's iron-loving material sank inward during differentiation, and later impacts likely helped modify the accessible inventory. But the deeper origin of the atoms is older than geology. Before gold could sit in a vein, a meteorite, a circuit, or a ring, its nucleus had to exist. That nucleus required an astrophysical origin. Earth did not manufacture it.
Mining did not manufacture it.
Human industry only moved it, purified it, shaped it, and assigned value to it. That is why the neutron star story holds attention. It connects an object humans treat as wealth to a process that has no use for wealth. A merger has no concept of rarity. It has mass, gravity, nuclear reactions, opacity, radiation, and time. Value comes later, on a small rocky planet, after billions of years of mixing and sorting. The metal feels close because it is close.
It touches skin. It passes through hands.
It sits in vaults, electronics, and spacecraft components. But its physical origin is not close. It belongs to a chain that begins with stellar death, compact remnants, neutron-rich ejecta, radioactive light, interstellar mixing, solar system formation, and planetary chemistry. That chain is the real scale shock. Return to the gold object now.
It has not changed. The ring is still a ring. The coin is still a coin.
The metal is still quiet under ordinary light.
What has changed is the scale behind it. You are not looking at something Earth invented.
You are looking at matter that survived a chain of events almost too violent for everyday language. Stellar collapse, compact remnants, neutron-rich debris, rapid nuclear assembly, ejection into space, interstellar mixing, and planetary formation. GW 1708-17 did not hand Earth its gold. It did something more useful for science. It showed astronomers the kind of event that can connect gravitational waves, gamma rays, kilonova light, heavy element signatures, and our process physics into one observed sequence. The proof was not one image. It was the order of arrival. Gravity first. Gamma rays 1.7 seconds later. A fading point in NGC 4993.
A kilonova changing color. Heavy element evidence and follow-up across the spectrum.
That is why the title works only as a mechanism, not as a literal shipping label.
2 dead stars can make gold like the gold in your hands.
They can make the neutron-rich conditions where heavy nuclei form. They can throw that material into space, where later generations of stars and planets inherit the debris. The universe does not make precious metals because they are precious. It makes nuclei when physics permits it, then leaves small planets to discover what those nuclei can become.
A gold object is therefore
Not just an object of value.
It is a fossil from a violent chemical history.
It is a quiet piece of a process that once rang space-time itself.
And somewhere,
Long before Earth existed, in a collision like the one we finally caught from 130 million light-years away, matter became heavy enough to shine in your hand.